Hello and welcome to SAS Junior Math. Today we shall be looking at solving questions on exponential equation that can be reduced to quadratic equations. Now let's look at these questions. We are going to be looking at these questions one after the other. But first, let us analyze these questions. As you can see, this is how a this is how an exponential equation reduced to a quadratic equation. This is how it looks like. Unlike the previous questions we've been solving on exponential equation, we have been treating cases like something like this. We've treated cases like this. We've also treated cases like this. And so on and so forth. But the difference between this and the one we are about doing now is this, or let me put it like this. How can you recognize an exponential equation? This is how you recognize them. Number one, most of the questions on exponential equation reduced to quadratic equation has three terms. Let's not forget that a quadratic equation is the form of ax raised to power 2 plus bx plus c equals to 0. You understand? So, number one, we are going to look at the terms here. As you can see, I have 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so on and so forth. You can see this is 5 into brackets 6 raised to power x. I can as well say 8 into brackets 7 raised to power x, and I can as well say 6 brackets 9 raised to power x. But I purposely did it this way so that you can always see how it looks like, in what forms, in different forms at which it may come out in. And also, that is number one thing you should observe. Then secondly, you will observe that the first term is either a number that can be broken down to its square or its square. Let me put it like this. For example, 36. Let's not forget that in a quadratic equation, the first part is always raised to power 2. That is the quadratic, that's how it looks like. That's the quadratic equation. That's how it looks like. So, unlike this now, you can see this is 36 raised to power x. I know that I can as well say this is something as saying 6 raised to power 2x. This one, 49, I can as well say this is 7 raised to power 2x, and I continue my work. Or you may find the first term in this format, like 2 raised to power 2x, 9 raised to power 2x. Whenever you find something, whenever you find the first term, and that first term is kind of raised to power 2x or something, but raised to power 2, it's also a sign that that this is an exponential equation that can be reduced to quadratic equation. As you can see, this one has been broken down for us. 3 raised to power 2x plus 1. So for me to have seen 3 raised to power 2 something, it's also a sign that this is an example of an exponential equation reduced to a quadratic equation. And unlike the way you have been seeing this question, another sign you can see is, I've said this is first term, this one is second term, they are all together. I can say 7 into brackets 2 raised to power x, or 7 dot 2 raised to power x plus 10 equals 0. So this is the first term, this is the second term, and this is third term. First term, second term, third term. First term, second term, third term. First, second, third, first, second, third. However, you may come across questions that may be in form of 2 terms. That is also an exponential equation reduced to a quadratic equation, like 3 raised to power 2x minus 9 equals to 0. You can see questions like, but there is one thing that has made it to be exceptional, and that is what? That the first term is raised to power 2 something, or the number, it's such a number that you can easily find the square of it. For example, now this is 49. So it means that this 49 we are seeing can also be converted back to 7 square. And also, there's something you should note, that anytime if you see a figure here that is carrying raised to power x here, it is a sign that the first term will also be in form of that square. Don't worry, the reason why all these things is happening, you are going to know later in this video. But I'm just kind of giving you guys the intro on how it looks like. So this is 2 raised to power x. Automatically, the first term, I said the first term is maybe carrying something like raised to power 2x or raised to power 2 something. So this is 2 raised to power x. Automatically, this is going to be 2 raised to power 2x. This is 9 raised to power x. Automatically, this is going to be 9 raised to power 2x. So why am I saying this? I'm saying this because when we get to this 7 raised to power x, and we are seeing 49 here, so it's a sign that this first term needs to be something raised to power 2, and you're going to continue with what you have here. So this is 7 raised to power x. Automatically, I can as well say this is what? 7 raised to power 2x. Because I know 7 times 7 is 7 raised to power 2 is 49. So 7 raised to power 2x. Unlike this, I can see 6 raised to power x. So automatically, this has to be what? 6 raised to power 2x. So at times, the figure you find here in the second term, most especially the one that is carrying a letter, kind of defines how our first term will be. That is, if you want to recognize an exponential equation that can be reduced to a quadratic equation. And unlike this one that you can just see, this one equals to 4, 2 raised to power 2x equals to 8, 0.0 something, 0.04 raised to power x plus 1 equals 16. Instead of the difference here and this is that in this case I'm seeing minus, I'm seeing plus, I'm seeing minus, I'm seeing plus, I'm seeing minus, plus, minus, minus, and so on like that. Are you getting me? That is all equal to 0. That is another thing. And if you find questions like this, don't worry, this is a 3 time 1, 2, 3. The only thing we are going to do here is we are going to take this in so that it will be plus 6 equal to 0. So having known that, we are going to begin our journey. So now let's start with the first question. The first question says 2 raised to power 2x minus 7 dot 2 raised to power x plus 10 equals to 0. So how do we solve this? Now, let me write this question again. 2 raised to power 2x minus 7 dot 2 raised to power x plus 10 equals to 0. So, number 1, this is a question. It has 3 times 1. This second is the third one. And the first term is having raised to power 2 something, 2x here. And we have the second and third term. So what you are going to do is this. The first step you are going to do is to make this our first term to look like this second term. Let's not forget that the second term is 7.2x, which is same thing as saying 7 times 2x or 7 into bracket 2x. So our aim is to make our first term be like this second term, this one in particular carrying raised to power x. So what do? I can say that this is 2 raised to power x all into bracket 2. Now what has happened here? Nothing much has taken place. I only swapped the position of this product. So if I say 2 times x is 2x, x times 2 is also 2x, but I can as well switch it to this x2. What did I do? Let's not forget that the rule of multiplication says that a times b, that is a commutative rule, that A times B equals B times A. So if I say X times 2, I can say 2 times X. I can as well say X times 2. You understand? So they will give us the same um, answer. It's just that the arrangement, though in a normal way, the arrangement has to be a number before a letter. But just because of what we want to achieve with this one here, that is why you see me swapping the positions of the power. Minus 7.2 raised to power x plus 10 equals 0. Now it's now beginning to make sense here. Then from here I will say let 2 raised to power x equals any letter. Let's say v. Now, anywhere you see 2 raised to power x, you replace it with v. So I will say this is v squared minus 7 dot v plus 10 equals 0. So I just multiply out, and this is simple sense v squared minus 7v plus 10 equals 0. Aha! So this one has now been what? Reduced to a quadratic equation. Now, how do we go about this? The next thing we are going to do is we are going to solve this using factorization method, and and the first thing we are going to do is we are going to multiply the first term times the last term. The first term here is 1. Let's not forget this v square is like saying 1v square. So we are going to multiply the coefficient of v square, which is 1, and the constant term here, which is 10. So I will say 1 times 10, that is 10. Then the next thing we are going to do is we are going to look for two numbers. These two numbers, when you multiply them, it gives us 10. And when you add them, it gives us, or subtract in this case, it gives us what? Minus 7. So that we're going to do. The first thing we are going to do is to list out the factors of 10. So the factors of 10 are 1, 2, 5, and 10. 1, 2, 5, and 10. And if I want to merge the the possibilities of getting 10, and it's going to be 1 times 10, 2 times 5, 5 times 2, 10 times 1. These are the possibilities. And of which I can still make use of this one. 1 times 10, 2 times 5. Now the next thing, because I know that the rest are still the same, like 5 times 2 gives me, still going to give me the same result as 2 times 5. 10 times 1 will give me the same result as 1 times 10. But in order not to complicate things, let's just leave it this way. So these are the two, let's just say these are the two unique possible ways of getting 10. Now the next thing we are going to do is we are going to look at these two figures, and we pick the one that looks like, when you join them or when you combine them together, it's going to give us 7. And we know obviously that it can never be 1 times 10, because I know that 1 plus 10 is going to give us 11, or 10 minus 1 is going to give us 9. It doesn't really look like our middle term, which is what? Minus 7. So the only multiplication combination that we can look at here that makes it look like the middle term is 2 and 5. Why? Because 2 times 5 is automatically 10, and 2 and 5, if I add them together, it gives me 7. But the issue now is, how are we going to work on the signs? Now, I've picked this one because I know 2 times 5 is 10, and 2 and 5, if I join them together, in either way, it gives me 7. Now, let's look at this. Now, how do we fix the sign? I'm seeing minus 7 here. So, and I'm seeing plus 10 here. I know that if I should put minus 2 times minus 5, then I will know that minus times minus is what? Plus. 2 times 5 is 10. Then minus 2 minus 5 will give me minus 7. So we have found two factors that when you multiply, it gives us positive 10. And when you add, it gives us negative 7. And what is that number? Minus 2 and minus 5. Please, let's not forget that minus 2 minus 5 is something as minus 2 plus minus 5. That's why I said when you add them, it's going to give us negative 7. So in this case, plus times minus is automatically minus. That's why you see me writing. So I can as well say minus 2 minus 5 equals minus 7. Now let me summarize this thing again. The first step you do is make sure you multiply the coefficient of the first term, which is 1, and the constant term here, that is 10. When you multiply them together, you will now find two numbers that when you multiply them, it gives us this last term, and when you add them, it gives us what? The middle term, which is minus 7. And from the look of things, from the options given to us, 1 and 10, 2 and 5. So from here, I can as well say that 2 times 5 makes more sense here. Why? Because I know that when I when I multiply them together, it gives me 10. And when I do some kind of addition on it in one way or the other, it gives me minus 5 because I know that 2 and 5 makes sense when I combine and it gives me this 7 here. So that's why I'm choosing this. That's why I chose 2 times 5 here. So in my analysis, I know that the only way I can do for me to get my negative 7 is if I should multiply, if I should put two negative signs on this figure so that minus 2 times minus 5 will give me plus 10 because I know minus times minus is plus and minus 2 minus 5 equals minus 7. So from here I'll write v squared minus 7v plus 10 equals 0. I'm writing this again. Now v squared plus 10 equals 0. Now, I want to replace minus 7v with something. What am I replacing it with? I am replacing it with this, our two new factors here, which is minus 2v minus 5v. Now, minus 2v minus 5v obviously gives us minus 7v. So I am writing this v square, I'm writing it again, 10 and 10, I've written this down again. The only difference here is that minus 7 has now been replaced with minus 2v minus 5v. So let's proceed. Then from here, we are now going to bracket them in pairs. Then what is common? V squared minus 2v. V is common. Why? Because v is here and I can find an element of v here. So if I should pick one of this v, then what is going to be left here? That is v minus 2. So minus this minus sign here, you write it here. What is common here in 5v and 10? That is, what is that thing that what is that number or letter that you can find in the first side here and you can also find it in the second side here. So from here I cannot say v again because v is only on this side but v is not on this side. So we are going to look for the number that can be on this side and can also be on the second side. So from the look of things here, 5 is that number that is here and 5 is also on the other side. Now, there is a way you can do it. As you can see, v is common here because I can find v in v squared. Don't forget that v squared is v times v, and I can see v here. So if I should bring out this v, I can use this letter to divide every term that I can find in this bracket. For example, v, I know that v squared divided by v will give me v. This is v here. And I know that 2v divided by v cancels v, I'll find 2 here. So that is another way of what? Of doing that. Minus, I know that I can find 5 in 10. I know that 5 is a factor of 10 and 5 is also a factor of this 5 here. Are you getting what I'm saying now? So now, what am I going to do? I'll just bring out the 5 because I know 5 is common here and 5 is common here. Then what am I going to do to get what is going to be in this bracket as a means of division? So I can say 5 divided by 5v, it gives me v plus 5 in 10, 2. Now there is something that I want you guys to know, that 5 in 10 is 2. I can as well say minus divided by plus will give me minus. Now before we proceed, let me just write something down here, that plus times plus is plus, minus times minus is plus, plus times minus is minus, minus times plus is minus. What do we observe? You can observe that two signs that are the same. When you multiply them together, it's going to give us positive. Two signs that are also the same, which is negative again. When you multiply it, it gives us positive. Two different signs gives us negative. So plus times minus is minus, minus times plus is minus. The same rule extends to division. So I can as well say plus divided by plus is plus, minus divided by minus is also plus, plus divided by minus is minus, minus divided by plus is minus. Now these two, please, I want you to have a grasp of them and then use them judiciously. Now from here we can as well see that v, if I should bring out v, if I should bring out one v here, I will know that it's only one v that will be left. And if I should bring out this v, I will know that there's no v here, so only two that will be here. If you can use that style, there's no problem. But if you know you're going to be confused, you can always use the division style by saying v divides by v goes in v square, you have v, v divided by 2v, you have 2. This minus, you put it down, 5 goes in 5v, it will have v, minus divided by plus, as you can see, it gives us what? Minus, and 5 goes in 10, and we have 2. So, now what do we observe? We have observed here that we have noticed here that this and this are the same. If they are not the same, it means that you need to check what you have solved and cross-check, or you need to go back and retrace your steps to see where you've gone wrong. So from here, I will just pick v minus 5. This v and this minus 5 and v minus 2. Let's not for v minus 2 and this, they are common, so you can just pick one, or equal to 0. So the next thing we are going to do is, I'll say v minus 5 equals 0, or v minus 2 equals 0. Now, let's quickly look at the origin of v minus 5 equals 0 or v minus 2 equals. What does this statement mean? It means that if this is a times b equals to 0, that the condition that can make a times b to be equal to 0 is if one of this letter is equal to 0. That is the only condition that can make this to be equal to 0. For example, if a is 0 times b, automatically I know it is 0. Or if b is 0, automatically I know that the answer here is going to be 0. So, or it's even possible for the two sides to be 0, and the answer I get will be equal to 0. So now we have product of two brackets equal to 0. So it means that v minus 5 equals to 0, or v minus 2 is equal to 0. Now we can know where the origin came from. So if a times b equals to 0, it means that a is either equal to 0 or b is equal to 0. That is, if a is equal to 0, automatically 0 times b equal to 0. If b is equal to 0, automatically a times, if b is equal to 0, it means it's going to be a times 0 equals 0. If a is equal to 0, it means that 0 times b equals 0. So that is why you find something like this. Now, v, take this one, equate this one, v equals to 5, or v equals to 2. Now, we are done with the quadratic, but we haven't stopped. All right. So, from here, we are going to recall that 2 raised to power x equals to v. So anywhere we see v, we are going to put the value 5. That is v when v equals 5. So we recall that 2 raised to power x equals v. Then we have 2 raised to power x equals 5, or 2 raised to power x equals 2. Now, from what we have seen so far, we can see that this is 2 raised to power x equals 5, and this is 2 raised to power x equals 2. If you look at the one on my right hand side, you will observe that the base here are equal. But in this case, this is 2 raised to power x equals 5. So this has to do with what? Exponential equation with different bases. And I've explained that explicitly in my last video. But notwithstanding, since we have come across this here in this video, we are also going to look at it extensively. So how do we solve problems like this? Let's now, so we have 2 raised to power x equals 5 or 2 raised to power x equals 2. So now let's solve this. From what you have observed or from what you have seen so far, we've seen that 2 and 5 are different bases. So how do we do it? The way we can do it is introducing a technique which is called the logarithmic property. And we are going to take log on both sides. Take log on both sides. So we have log 2 raised to power x equals log 5. And in this case, we are going to use what is called the power law of logarithm, or the logarithmic power law that tells us that log a raised to power x base n equals x log a base n. So that is the property we are going to apply here. So which means that the power we see here, we are going to take it to its front, or we are going to take it to the front of log. So we have x log 2 equals log 5. Because we want to find the value of x, so we divide both sides by log 2, we divide both sides by log 2. So this cancels and we have x equals log 5 over log 2. Then the next thing we are going to do, so the next thing we have to do is to find the log 5. So we are going to find log 5. Log 5. So we have 0.6990 divided by log 2 is 0.3010. So we divide both sides. So we have 0.6990 divided by 0.3010. And we have, so our x equals 2.322. So our x here is 2.322, and if you put the value of our x here and you write 2 raised to power 2.322, we are going to get our figures, which is going to be rounded up to 5. So now we look at the other side of the equation. Let's not forget that we said it is 2 raised to power x equals 5 or 2 raised to power x equals 2. So for 2 raised to power x equals 5, we've gotten our x to be 2.322. So the other part of it is 2 raised to power x equals 2. You can see that the difference here is that this is having different base while this is having the same base. Different base here, what it means here is that there is no way we can take this to its lowest common base that that will easily give us a whole number, and of which when you multiply it raised to power that whole number, you are going to get 5 directly. So in this case, the other way we can solve this out is to what? Is to introduce logarithm by taking logarithm on both sides. But in this case, there is no need for us to take log on both sides. Why? Because we can see that the base here are the same. So since it is like this, and automatically it means 2 raised to power 1, so I'll just say equate powers since the base are the same. So if I equate powers, automatically my x equals 1, because for me to equate powers means that the base are equal. So my x equals 1. So this is what I'm going to make use of since I've equated since the base are the same. So the answer to this, to the first question now is going to be x equals 2.322 or x equals 1. So that is the solution to the first question. However, please don't forget to hit the subscribe button. I'll be very grateful if you can like and share to your friends. Thank you. So from here, we are going to, now we can see this is 9 raised to power x, so this is 9 raised to power 2x, and this is, so this is an example of a quadratic, of an exponential equation that can also be reduced to a quadratic equation. So the first thing we are going to do is swap the position of this so that it will look like this one, minus 6.9 raised to power x plus 9 equals 0. So I'll say let 9 raised to power x equals r. So I'll say this is r squared minus 6 dot r plus 9 equals 0. So r squared minus 6r plus 9 equals 0. 6 dot r means 6 times r, and that's why you have 6r here. So in this case, the first term here is 1, and the last term here is 9. The first time, the coefficient of r squared here is 1, and the constant term here is 9. So the first thing I will do is I will say 1 times 9, and that is 9. You just write the combinations of 9, the two numbers that when you multiply it gives us 9. Like we have 1 times 9, we have 3 times 3. So let's use this. Now, from here, you just pick. I know that 1 times 9 will definitely give me 9, but if I should do the other combination, the other side of it, like to add or to subtract or whatever, it's going to either give me 10, or if I add them together it gives me 10, and it doesn't look like the middle term here, and or if I subtract it gives me 8, it doesn't really look like the middle term here. Now here I know that 3 times 3 is 9, and the combination of these two, like in form of addition, is going to give me 6. Now I have seen 6 here, so I'm going to make use of this one because the multiplication has given me the 9, and the addition in one way or the other, that is, we are going to put the signs at the end of the day. But so far it has given us a combination of that when you add them, it's going to give us a figure like this. Then we are going to make use of this number. So we are going to make use of 3 times 3. Now the next thing we are going to do is how do we figure out the numbers, the signs rather. So in this case, when you have something like this, so the answer to it is we are going to put -3 and -3. -3 and -3 always work for quadratic equations that has to do with negative in the middle term and positive on our last term. If you look at the first questions we did, we had negative and negative. We had, I think we had -2 and -5, because I know that -5 minus 2 is -7, and -5 times -2 is +10, because minus times minus is plus, and -5 minus 2 is -7. So on this note, when you are having a quadratic equation and you find notice that the negative term is, the middle term is has a negative sign, and the last term has a positive sign, then when you find two numbers that when you succeed in finding these two numbers, then it means that what's the signs that will be in front of these two numbers will be negative and negative. Why? Because when you multiply this negative, it will accept this positive by saying plus 9, that is -3 times -3, and also -3 minus 3 is -6, which is the middle term. So let's not forget that when you find negative at the middle and the last term to be negative and positive, then the two signs you find, the two factors you find, make sure that negative becomes their sign, so that so let's proceed. So now we've known that 3 and 3 are the two possible combinations that gives us 6. So the only thing we are going to put is the sign, and the sign is going to be negative and negative. So I will write this down again. We're going to write uh, r squared minus 6r plus 9 equals 0. So r squared, this is 9. So what am I going to do here? I'm just going to write, instead of writing minus 6r, I'll write minus 3r minus 3r. Please let's not forget that we found minus 3 and minus 3, meaning that meaning that if I want to put them into this equation, then I'm going to put minus 3r minus 3r. This minus 3 and minus 3 has been replaced with what? Minus 3r and minus. So this is it. So as to what? To make it look like the middle term here, which is minus 6r. So the next thing I'm going to do is to bracket them in pairs, and what is, we can find r square. R square means r times r, and we can find r here. So it means that let's not forget that we have to look for either numbers and letters, or letters or numbers. Just look for something that is common on both sides. So here I can see that r is common here and r is common here. Let's not forget that r square means we have two r's here. So if we have two r's here, it means I can find r here, and that r I can also find it here too. So if I should bring one that is common, I think r is common. Then if I should bring out this r, this r is part. So if I should bring out this r, it means what? One r here minus, I've brought out this r, so it means that there's going to be nothing here. If this does not resonate well with you, you may use the division method by saying r squared divided by r, that is r times r divided by r cancels r, you can find r here. And let's not forget that this is plus, there's a positive sign at the back of r, and plus divided by minus will also give us minus. Then r divided by 3r will give us 3 minus. What is common here? I can see that r is here and r is not here, so r cannot give me, or r cannot be the common letter. So we look at the number side. I can see 3 is here, and I can also see 9. I know that 3 is a factor of 9, and also it's a factor of 3. So it means that the common factor here is what? 3. So the same method, 3 divided by this 3r is going to give me r, minus divided by plus is minus, 3 divided by 9 is 3, equals to 0. Or, since you brought out r, you now put the rest. Since I brought out r, it means r is going to remain in this bracket. I'll put the r here, and I brought out 3 here. So it means that 3 is going to be the remaining, because 3 is common here, and I brought out 3. I know that 3 divided by 9 is what? Is 3. So that is why I see me writing down 3 here. Then from here, I can as well say this is r minus 3. This, you pick this and gather them together as one, and these ones are also common. I'll say r minus 3 equals 0. So it's same thing as saying r minus 3 equals 0, or r minus 3 equals 0. So we have r equals to 3, or r equals to 3. Then here, I can as well say, I'll now say recall that r equals to 9 raised to power x. So we should recall that r equals to 9 raised to power x. So at this juncture, when you get to this level, to this stage, you are now going to replace r with what? 9 raised to power x. So I'll say this is 9 raised to power x equals to 3, or 9 raised to power x equals to 3. So I can just take this one to its lowest common base, which is 3 raised to power 2x equals to 3. Let's not forget that 9 is same as 3 raised to power 2, and there is x here before, so that's why the x is there. Or 3 raised to power 2x equals to 3. Then from here, we know that we have succeeded in making the base to be equal, and I will say equate powers. So it's going to be 2x equals to 1 or 2x equals to 1. Then divide both sides by 2 because I want to make x to stand alone. So x equals to half or x equals to half. So I can say x equals to half twice. This, I can see it in two. I can see that's the same thing in two places here. So that's going to be our answer. So we move on to the third question. Move on to the third question. (49 raised to power x minus 8.7 raised to power x plus 16 equals 0. So now we have 49, unlike our first question and our second question, where we have something that is raised to 2, that is 2 raised to power 2 something, 9 raised to power 2, So 49, and we have seen 7 raised to power x here. So it means that we are going to, even without even looking at this, but though this is a sign, but we can as well break this one down to 7 raised to power 2x minus 8.7 raised to power x plus 16 equals 0. So you have to break it down like this first, then we now proceed. So I can as well say this is something as saying 7 raised to power x 2, 2x, x2, just swapping the positions of the power, minus 8.7 raised to power x plus 16 equals to 0. Then I can as well write that let 7 raised to power x equals to w. So now it's going to be w squared minus 8.w plus 16 equals to 0. So I can as well say this is w squared minus 8w plus 16 equals 0. The same thing again. The first term, the coefficient of w squared is 1, and the constant term here is 16. So I will say 1 times 16, that is what? 16. So from here we have 1, the factors of 16, or the two numbers that when you multiply it gives us 16. We have 1 times 16, 2 times 8, 4 times 4. Then, and I think these are the 3 unique possible combinations we have for 16. So now look at these 3 combinations we have. Can you tell us the 2 numbers that when you multiply it gives us 16? And looking at the possible combination, that when you kind of add, or when you join these 2 figures together, it's going to give us something that looks like, it's going to give us 8, to be straightforward, to be precise here. So can you tell us the answer? That's right. So we have 4 times 4. This is our best and our sure option here. Why? Because 1 times 16 is 16, and the possible combination of these two cannot give us minus 8. 2 times 8 is 16, and the possible combination of these two, that is by when you add them by using different signs in it, will not give us minus 8. But this 4 times 4, which is equal to 16, it means that when you join the 2 possible combinations on it, it's going to give us 8. So from here, we are now let's not forget that I said something, that when you have a negative at the middle and a positive at the end, then when you find your factors, the 2 factors will always end up to be negative, negative. So here we have the 2 possible combinations will now be minus 4 and minus 4. Why? Because minus 4 times minus 4 gives me plus 16, and minus 4 minus 4 gives me minus 8. Let's not forget that. So this note will continue. So we are going to write w squared minus 8w plus 16 equals 0. So I'll write w squared, I'll write plus 16 here equals 0. So what I'm going to do is to replace minus 8w with these two factors are found. So which is going to be minus 4w minus 4w. It has replaced minus 8w. Please let's not forget that when mainly we put these two factors in this equation, we are going to change it to we are going to change it with this letter so as to look like this minus 8w. Then we separate them in pairs, and in this case, what I'm going to do, I can see that w, and there's w here and there's also w here, so I'll say w is common. Then I'll have one w here, because once I take one of the w out, it will be left over here is going to be 1w minus. If I take w out, then there's no leftover here, so we're going to be having minus 4, or you divide like what I did in my previous examples. So what do we have? This minus, there's minus here, so I'm writing this minus down. It is here, I'm writing it down like that. Now we have 4w and 16. So what is common in 4w and what is common in 16? So in this case, the letters are not common because I can only find w here. I cannot find w at the other side. So now here we have so the common number here is going to be 4, because I know that 4 is a factor of 16 and is also a factor of these 4. So and let's not forget that we have to select the highest common factor here. We have to select the highest common factor. Why? Because I know that 2 is also a factor of 1, 2 is also a factor of 16, but 4 is the right, but 2 is not the highest, so we have to select the highest common factor, which is what? Which is 4. So then I'll have w, minus divided by plus is minus, let's not forget that. Then 4 divided by 16 is also 4 equals to 0. So we have w minus 4. So when you find yourself in this kind of situation that the two figures are the same, you should know that your mind should be at rest, that it means you have gone thus far in doing the right thing. So what am I going to do? I'll just write w minus 4. I'll pick this w and this minus 4, gather them here, and this minus w minus 4 and this one, they are very common, so I'll also pick one of it and equals to 0. Then I'll as well say w minus 4 equals 0, or w minus 4 equals 0. So we have w equals to 4 or w equals to 4. Let's not forget that this minus 4 goes out, it becomes a positive 4. This minus 4 goes out here because I want to make w stand alone. So what am I going to do? So minus 4, when minus 4 comes here, it becomes plus 4. As w equals 0 plus 4, or w equals 0 plus 4. So we have w equals to 4 or w equals to 4. Then we now recall that what? That w equals to 7 raised to power x. So from here, let's recall that w equals 7 raised to power x. So if w equals 7 raised to power x, so it means that we are going to substitute 7 raised to power x for w, where w equals 4 or w equals 4. So we have 7 raised to power x equals 4. Now we have said before that recall that w equals 7 raised to power x, or 7 raised to power x equals 4. So now we have come again with, as in we have come across two different bases here. So what we need to do is to take log on both sides. So we have log 7 raised to power x equals log 4. Then from here, I can say this is x log 7 equals log 4. We divide both sides by log 7 to isolate x, just to make x stand alone. So this log 7 cancels log 7. We have x equals log 4 over log 7. So I check my calculator. What is log 4? Log 4 is 0.6021 divided by log 7 is 0.8451. Then my x equals, so say 0.6021 divided by 0.8451. Then my answer is 0.7125. So this is the value of my x. So at this juncture, if I put the value of x to be 0.7125 in this equation, I should be having 4, or approximately to 4. So, and if I should insert it here too, so my answer, which means the method I use here can also be used for this other side of the equation. So my answer at the end of the day is going to be x equals 0.7125 twice, because it is the same thing. What you have here is also what you have here. The same method you use here will also be the same method you will use for the second equation. So we'll move on to the next question. 2x plus 1 plus 3 raised to power x plus 2 minus 12 equals to 0. So how do we go about this? 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 Now, the first thing we are going to do is we are going to break this down. Like, let's not forget that x raised to power a plus b is something as saying x raised to power a times x raised to power b. So this, and I can also as well say that x raised to power a times x raised to power b is also x raised to power a plus x raised to power plus b, rather. So looking at this now, you can see that this goes in line with this, what we have up here, and it means that I can as well break it down to x raised to power a times x raised to power b. So that is what we are going to do here. So we have so we are going to write 3 raised to power 2x dot 3 raised to power 1, or times 3 raised to power 1 plus the same thing goes here too, 3 raised to power x times 3 raised to power 2. X raised to power a plus b is something as saying x raised to power a times x raised to power b. So that's how it's going to be broken down, equals to 0. So then using that method, then I can as well, because of this 3 raised to power x here, so I can say this 3 raised to power 2x, let me just rewrite this, plus 3 raised to power x times 9 minus 12 equals to 0. So we can say this is 3 raised to power 2x, that is, we have 3 raised to power 2x dot 3 plus 3 raised to power x dot 9 minus 12 equals to 0. So now I can as well say this 2x can be written as 3 raised to power x raised to, I've swapped the position, dot 3 plus 3 raised to power x dot 9 minus 12 equals to 0. And I can as well say let 3 raised to power x equals to q. So we have q squared dot 3 plus q dot 9 minus 12 equals to 0. So we have 3q squared plus 9q minus 12 equals to 0. So this turns to become a quadratic equation. Now, this is quite different from the ones we've done so far. This one is having 3q square, unlike the ones we've been treating before. That has to do with the coefficient of q square to be 1. So in this case, the coefficient of q square is 3. But I've observed something also. I've also observed that I can divide all through with a common number. It is also allowed in order to reduce or to lessen our load. So it's going to be, if I divide all through by 3, I will have q squared plus 3q minus 4 equals to 0. So we can see, though we can continue with this 3q squared plus 9 minus 12, the implication here is that we are going to be dealing with high figures. We are going to be going around with high figures. So why not, if you have the opportunity to reduce, if you can see that you can find a common number that can divide all through, then why not go with a lesser figure? So from here we have q squared plus 3q minus 4 equals 0. Then we do it the way we've been doing it. I'll say this is 1 times minus 4, which is what? Minus 4. That is, the coefficient of q squared is 1, and the last term here, a constant term here, is minus 4. So it's going to be 1 times minus 4, and it's going to give us minus 4. And we are going to look for the possible combinations of minus 4 here, 4 generally. So it's going to be 1 times 4, and we have 2 times 2. So looking at this, these are the two unique possible combinations of 4. So now we are going to look at the combinations here. That the one that when you multiply, it makes it look like 4, and when you add also, we are going to have plus 3. And what are the two if you look at it, we are going to get it from 1 times 4. So this 1 times 4 is the possible, is the right option for us. So from here, now the next thing we are going to do is how we are going to do it. We are going to, like, this is 1, and we know that is 1 times 4. That is, this is the right one. So the next thing we are going to do is how we are going to put the signs in the right way or in the right order, in such a way that when you multiply, it's going to give us minus 4, and when you add it, it's going to give us plus 3. So let's do it this way. I know that if I should put minus here and I have 4 here, I know that minus 1 times 4 will give me minus 4. I know that minus 1 plus 4 will give me 3. So I think minus 1 and 4 is the right option for us, because let's use the other way around. Let's say my minus is at 4 here. So let's say I have 1 times minus 4. I will automatically have minus 4, which is correct here. But when I intend doing some kind of addition to it, like 1 plus minus 4, that is 1 minus 4, I will automatically have minus 3. And the middle term here is plus 3. So this will not go. So the right sign to put is where? At this side. So the only thing, after finding the number, there is a possible combination on what will give you 3. The next thing you are just going to work on is the signs. So, and I believe that, and the sign is not going to give us too much issues like that. So the two possible combinations is going to be minus 1 and plus 4. So I'll write, so from here, I will write the equation. Let's not forget that minus 1 and plus 4 are the two possible factors for us. So we write q squared plus 3q minus 4 equals to 0. Q squared plus 3q minus 4 equals to 0. So from here, I will have q squared minus 4 equals 0, plus 3q will be replaced with what? Minus q plus 4q. So let's not forget that minus q plus 4q minus 4 equals 0. Minus q plus 4q will give us 3q. And so that is why it has been replaced like that. Then the next thing I will do is to bracket them in pairs. So now here, what is common here and here? Q and Q. So Q is automatically common. Then if I should put my Q here, what will be left here? Q will be left here minus 1. Because I know that is already out. So what is going to be here? No, the only thing that will be here is the 1. Because Q divides Q, we have 1. Q divided by Q squared will give us Q. Plus, what is common here? 4 is here and you can find 4. So 4 is common here. Then 4 divided by 4Q is what? Q. Plus divided by minus is minus. 4 divided by 4 is 1 equals to 0. Then we have Q minus 1 and Q minus 1, they are the same. So we are going to write Q minus 1 and Q plus 4. This Q and this plus 4 is what we're going to write here equals to 0. So from here, what do we have? I can say this is Q minus 1 equals 0 or Q plus 4 equals 0. And Q equals to, when this minus 1 comes to the other side, becomes plus 1, or Q equals to, when this plus 4 passes through the equality sign, because I want to make Q to stand alone, it's going to give me what? Minus 4. Let's not forget that we have 0 plus 1, and we have 0 minus 4, because this 0 was here before. Plus 4 coming here becomes minus 4, so we have Q equals to 1 or Q equals to minus 4. So we have so we are now going to recall that Q equals 3 raised to power x. So anywhere we see Q, we replace it with what we have here. So I can say 3 raised to power x equals to Q. So anywhere we see Q, so now we have 3 raised to power x equals to Q equals 1 here, so I'll write 1, or 3 raised to power x equals minus 4. Now, I have seen 1, I have seen minus 4 here. Now, this 1 here, you may be thinking that, does it mean that there is no solution to this? This answer to this is that, because if we have different base, the answer to this is that there is solution. Anytime you see figure 1 like this, I can always and as well convert it to what? 3 raised to power 0. If my base here is 4 and I see 1, I can as well convert to 4 raised to power 0 so that the base can be the same. But because the base here is 3 and we have 3 raised to power x and is equal to 1, I can as well convert this 1 to what? 3 raised to power 0, because I know that anything raised to power 0 is 1. So, or 3 raised to power x equals minus 4. So automatically, we can see that the base here are different and there is a negative here. It means that there is no number that I will use here, that I will put here to replace x, that if I should multiply it 3 raised to power that number, that it will give me minus 4. That is not possible. It's not possible for me to find a value of x that once I raise it to its power, it's going to give me minus 4. So in this case, we say that there is no solution to this. And here, what do we have? We say equates powers. When you equate powers, we have x equals to 0, and that is our answer. Wow. So we are going to be rounding up with the last question. 36x raised to power x minus 5, open bracket 6 raised to power x equals minus 6. So let's look at how this can be solved. So the first thing we are going to do is to take this minus 6 in, so it's going to be equal to 0. So we have 36 raised to power x minus 5 all into bracket 6 raised to power x plus 6 equals to 0. So, this 6 raised to power x has given me a sign that this 36 can be also be taken to 6 raised to power 2x, because 6 raised to power 2 is automatically 36, and we have x here before, minus 5 into bracket 6 raised to power x plus 6 equals to 0. And I can as well swap the powers, like change the position. So it's going to be 6x to make it look like this one. So 2 minus 5 into bracket 6 raised to power x plus 6 equals to 0. So I will say recall that 6 raised to power x equals t. So I will say t squared minus 5. Anyway, 6 raised to power 6 raised to power x, now we replace it with t. So t squared minus 5t plus 6 equals 0. So the same style again, we look for two numbers. The first thing we are going to do is to multiply the coefficient of t squared, which is 1, times the constant term of the ladder is the last term, which is the constant number. That is what? 6. So we have 6. Then we are going to look for the possible combinations of 6, the factors of 6. That is 1 times 6, 2 times 3. So these are the two unique possible combinations of 6. Let's not forget that we also, though we have 6 times 1, which is 6, and we also have 3 times 2, which is 6. But whichever way, we can still pick this, we can still make use of this one, because what we are looking for can still be gotten from these two unique combinations we have here. So let's look at them. If I should pick 2 times 3, I know it is 6. But looking at the 2, is it possible for me to add and or something that is going to give us minus 5, and I think this is going to be the right option for us, because I know that number one, I've said it before, that when you have negative and positive, then the two possible combinations are going to be numbers that when you multiply, it's going to give us positive, and when you add, it's going to give us minus 5. So from here we have the right one is going to be minus 2 and minus 3. Why? Because minus 2 times minus 3 will give me plus 6. Minus 2 minus 3 will give me minus 5, which fits in to what we are looking for. So from here, I'll write t squared minus 5t plus 6 equals to 0. So, and let's not forget that we've chosen the two factors that fit it are minus 2 and minus 3. So we have t squared minus 2t minus 3t plus 6 equals 0. This one, you can see that minus 5t has only been replaced with what? Minus 2t and minus 3t. Then the next thing we do is to bracket them in pairs. Then t is common here, and if I should divide, I have t, which is the leftover, the remaining, minus 2. This minus, write it down. Then what is common here in 3t and 6? 3, because 3 is a factor here, and 3 is also a factor of 6. So into bracket t, minus divided by plus is minus, then 3 and 6 is 2 equals to 0. So t minus 2, they are very common, so you can say t minus 2 into bracket t minus 3 equals to 0. Then we now say recall, and I can as well say t minus 2 equals 0, or t minus 3 equals 0. So t equals to 2. When this minus 2 comes to the other side, it becomes 2, or t equals to 3. I will recall that what? That t or that 6 raised to the power x equals t. So we recall that 6 raised to the power x equals t. Substitute the value of t for 6x, so 6 raised to the power x, well, we will find it here in this equation. So we have 6 raised to the power x equals to 2, or 6 raised to the power x equals 3. As usual, we take log on both sides, so we have log 6 raised to the power x equals to log 2, or log 6 raised to the power x equals log 3. So from here, I can say this is x log 6 equals log 2, or x log 6 equals log 3. We divide both sides by log 6 here, and we divide both sides by log 6 here also. So this cancels, we have x equals log 2 over log 6, or this cancels, we have x equals log 3 over log 6. So x equals, then I check my calculator for log 2. So here we have 0.3010 divided by log 6. I have 0.7782, or x equals, let's look for log 3. We have 0.4771 divided by log 6 is 0.7782. So x at the end of the day, let's check this out, 0.3010 divided by 0.7782. So I have 0.3868, or so we have, let's check the other one, 0.4771 divided by 0.7782. Then I have 0.6131, and that is our answer. Thank you once again for watching this video, and if you like this video, please don't forget to give it a thumbs up, like, subscribe, and share. Thank you very much.